Welcome to the Illumination Talks. One of the great mysteries of history is the date of the pyramids, the megalithic pyramids, the ones at Giza and Dashur, because we cannot date stone. Well, the solar boat, which lies at the foot of the Great Pyramid, was dated to 2600 BC, because that's wood, of course. But was this boat contemporaneous with the building of the pyramids? We don't know. In 1985 and 1995, carbon-14 dating of carbon fragments was done in this region. 300 fragments were taken from Saqqara and Giza, and a few from Dashur as well. And they came out with dates between 2500 and 3000 BC. But do those dates count? Well, the dates at Saqqara don't count because that's not a megalithic site, so that really doesn't count. And there were no controls done on this dating, so there was no dating of, say, Roman buildings at all. And Professor John Hale this is a decade later, Professor John Hale has come up with a new method of dating lime mortar instead of fragments of charcoal, which is a much better method because you will know exactly where the mortar comes from. Basically, he's dating the CO2 that is absorbed by quicklime as it turns back into calcium carbonate and becomes mortar. So by this method, it contains actual CO2 drawn from the air during the construction period. It's a much more secure method. And the finest of pink mortar is available on the Dashur pyramids. It's just sitting there. You can almost pick it off yourself. But no carbon-14 dating has been done on the mortar in the pyramids. You could also do thermoluminescent dating. All you would need to have to do is actually take off a block, one of the casing blocks presumably, and measure the surface that you've just exposed. So measuring a surface that's been covered ever since the pyramid has been constructed. That hasn't been done either. That would be an interesting test. Anyway, please bear in mind as we go through the rest of this talk that everybody thinks that the carbon-14 dating has conclusively dated the pyramids, the megalithic pyramids, to between 2600 and 2800 BC, some 4,700 years ago or so. But I'm going to show some alternative evidence. So what other alternative evidence is there? Could we date the pyramids via the pharaohs who built them? Well, unfortunately, I don't believe that the pyramids are tombs. No mummy has ever been found in a tomb. And the chambers are completely bare. There are no hieroglyphs, there are no drawings, there's nothing. This is at Giza and Dashur, the megalithic pyramids. And no pharaoh in their right mind would do this, to go into a burial chamber that didn't glorify their name or have texts from the Book of the Dead to show his soul how to get into the afterlife. It's unthinkable that any pharaoh would be buried in a tomb with no inscriptions. So these pyramids are not tombs, they're cathedrals. They're actually cathedrals to mathematics and to cosmology more than anything else. But if there are no inscriptions, then there is no evidence. The only evidence they've come up with, really, I suppose, is a couple of daubed cartouches in the top of the attic chambers in the Great Pyramid. They've been found in very suspicious circumstances, and they're not proper cartouches. In fact, the spelling the spelling of Khufu's name is actually wrong in those attic chambers. And the only statue we have of Khufu, which is often portrayed, is this one, which is only 20 centimetres high, I suppose. And that wasn't even found at Giza, that was found at Abydos. So, in short, there is no association, real association, between any pyramid and a pharaoh. So, putting the carbon-14 dates to one side for a minute, how else could we date the pyramids? Well, one method that's not been considered previously is erosion. If we can assume a constant rate of erosion, then the erosion depth on the surface of the pyramid will be proportional to the time the pyramid has been standing. Therefore, we could derive a date. But to do so, we'd need some sort of yardstick, something that would determine the erosion rate. And that something is a time differential. And we have that time differential in the date when the casing blocks were stripped off. And we know that they were taken off in the 9th century by Caliph al-Ma'mun. So now we have two dates and two erosion measurements. So we can compare the two and find a date for the pyramids. So let's look at the Great Pyramid. This is the base of the Great Pyramid. And on the left you can see the pavement that went underneath the pyramid and obviously beyond the pyramid. And I've sort of drawn in the casing stones in orange because the casing stones have gone. So where you see my lines going up on the right side, that's where the casing blocks would have originally been. And where the red arrow is, that's an area where there has been erosion ever since the pyramid was constructed. So for thousands of years, that piece of pavement has been eroded by wind and rain and sun and the feet of pilgrims and priests, and they've eroded away that pavement. So, much later on, someone came along. This was Caliph al-Ma'mun and his workers, and they stripped off all of the casing stones because it was pure white Tura limestone. It was very valuable, so they took it off to go and build mosques and palaces in Cairo. So, where the casing stones have been stripped off in the 9th century is now indicated by the blue arrow. And we have a differential here, obviously. You can see that there is a difference in the amount of erosion, but we would expect that. And remember that this is a difference in erosion on one block. This is not a join. I mean, it might look like a join in the blocks, but it's not. It's just where the end of the casing block was and where it's been stripped away. And it's left a line, obviously, along the pavement. And there is at least 10 times as much erosion on the red side to the blue side. So, if we know how long the erosion has taken on the right side, on the blue side, well, that was about 1,100 years, then we've had 10 times as much on the red side, about 11,000 years. So this rather simple but relatively reliable method seems to indicate that the Great Pyramid is 11,000 years old, assuming that erosion rates haven't changed. And there's no good reason why erosion rates should have changed in recent eras. Therefore, the Great Pyramid may have been built 9,000 years ago, not 4,500 years ago. So why has no one made a proper study of this, of differential erosion? Because you get this all around the pyramids. It's not just here in this one paving stone. All around the Great Pyramid and the Second Pyramid and down at Dashur, you can see the same differential erosion rates on the surface after someone stole all of the casing blocks. Okay, well, we can see similar erosion patterns at some of the other pyramids. So this is Saqqara. This is the period of Medum. And yeah, it's a funny pyramid, this one. It was built in sort of 3 stages. And the last stage is where they tried to turn it from a step pyramid into a true pyramid. And they used a rather friable, weak stone, and it's eroded quite a lot, much more than we see at the other pyramids. And that material has fallen down the pyramid and created a great pile of debris at the base. And I've sort of indicated the pile of debris here in these sort of purple stripes. In fact, to the right, you can see the great pile of debris is still there. What's happened is in this bare patch, they've actually done an excavation and taken the debris away and left the debris on the right-hand side. But originally, the debris went right to the top, where those purple lines are indicating. And the debris, over the years, over the millennia, covered up the base of the pyramid and protected the stones. So the bottom of the pyramid was more protected than the top. And we can see that in this demonstration here, where I take off some of the purple lines, and you can see at the top, where the side of the pyramid has been exposed for longest, there is quite a lot of erosion. And then if we take off some more lines, we see less erosion. And when we go all the way to the bottom, we see that the casing stones at the bottom of the pyramid are almost untouched, because they were covered up and protected by all the debris falling down from above. So this means that this pyramid has just eroded away, just through wind, rain, and sun, and the stone is eroded away and collapsed. It hasn't just fallen down, because a long time ago there was an archaeologist said that the entire pyramid had just fallen down, and that's why we had this debris pile at the bottom. But when they did the excavation of the debris pile, you could see that the debris was stratified. It had come down over decades, centuries, and millennia and built up a stratified pile of debris at the bottom. But how long does it take to erode away an entire pyramid? Just naturally, just falling down, bit by bit, stone by stone. Well, small piece of stone by small piece of stone, small grain of sand by small grain of sand, until the whole of the top of the pyramid has fallen away. How long does that take? Thousands of years. 10,000 years, perhaps? Well, we don't know, because nobody has done any proper research onto the erosion rates at the period at Medum. Oh, and another thing. When I went through this pile of debris at the bottom of the pyramid at Medum, the debris pile was full of beetle carcasses, and they were stratified. So obviously at the bottom, the very early strata would have started being laid down shortly after the pyramid had been built, give or take 500 years. The bottom strata would have contained beetles from the very, very early eras of this pyramid. And they could be carbon dated. But they haven't been, so we don't have a date. And that would be a much better carbon date, of course, because a carbon date could be wrong. It's difficult to trust it. But if you went down the stratified layer of the debris at the bottom of the Medum pyramid, you could take different beetles from each layer. And hopefully, if your dating method was correct, you would have a whole series of dates going further and further backwards into the past. Then you could trust your dating method much more than just by getting a single date, which is fairly meaningless, really. But that's not been done. Okay, going a little bit further north, going up to Dashur. This is the Bent Pyramid. Here it is. This is the base of the bent pyramid, what I call the Vega pyramid in one of my books, because it aligns with the star Vega. And again, you'll see a debris pile at the bottom of the pyramid. And the debris pile has covered up the casing stones and protected them. So where we have the blue arrows, you'll see that the casing stones are untouched. So this debris was piled up relatively early in the age of the pyramid. But the red arrows pointing to the rest of the casing blocks, well, there's quite a lot of erosion there. So there's a big erosion differential again. And the question is, when did this pile of rubble end up at the bottom of the pyramid? I mean, would the Egyptians allow rubble and debris to be collected at the bottom of the pyramid when it was new? No, I don't think so. So how long did it take before a pile of rubble appeared at the bottom of this pyramid? Was it maybe 1,000 years or so? Well, as it happens, the differential between the new-looking casing stones and the eroded is about 10 times again. So if this debris took 1,000 years before it was dumped at the bottom of the pyramid, then the rest of the pyramid is at least 10,000 years old. And again, look at the differential between the perfect casing stones and the eroded casing stones. The difference is quite marked. And we have another possible way of dating the pyramids. This again is the bent pyramid, because the bent pyramid is one of the few that still has most of its casing blocks on it, what I call the Vega pyramid. And as we can see from here, this is just one face of the pyramid, and you can see there are repair blocks all over it. I've circled most of them in red. And you can see that someone has looked at a stone, found it was eroding, there was a hole there, so they've chiseled out a nice square hole and put in a new block. They've made a repair. But this is all over the pyramid. I mean, here's another face, and you can see repair after repair after repair all over the place, over all four sides of this pyramid, from bottom to top. There are these repairs. And here's another one. Let's zoom in and we can have a look at a close-up of this block. And even this little crack, obviously the join between the two stones has cracked, so someone has chiseled it out and put in these nice little repair blocks. So, at some point in the distant past, someone has covered up the whole of the pyramid with an enormous great scaffold. And thousands of people have been up and down, chipping out the worn stone and putting in repair blocks. But when did this happen? It certainly wasn't in the Roman, Christian or Muslim eras. I mean, it was the Muslims who were just ripping off the casing blocks anyway, so they certainly weren't repairing it. Besides, if you look at some of these repair blocks, even the repair blocks have started to erode a little. They've been weathered. So it's been a while since this repair work was done. And how many years would it take before a pyramid needs repairing anyway? I mean, surely this is thousands of years before a pyramid would need repairs. And we know this from the casing blocks at the bent pyramid. And here is a section of casing blocks. Might not be exactly obvious what this is showing, but on the right, sorry, let's have a look at the left first. On the left, you'll see the casing blocks. And on the right is where they've been taken away about 1,000 years ago. But where they've been taken away, you're left with a fresh surface on the old stone, the stone that's still remaining. And if you run your hands across that surface, it's completely flat. There is no erosion whatsoever. So the stones that have only been exposed there for about 1,000 years have no erosion on them. So we can be fairly sure that when this pyramid was constructed, the face of the pyramid would have stayed in fairly good condition for thousands of years and not needed any repairs. How many? Well, we don't know, but just guessing, 6,000 or 7,000 years before you would need any repairs being done? Sounds reasonable to me. So who did these repairs? From the condition of the repair blocks, we can say it was several thousand years ago. And who was actually closely associated with this particular pyramid? Well, the only pharaoh that is associated with this pyramid is Pharaoh Sneferu from the 4th dynasty. That's about 4,500 years ago, which sounds like a reasonable sort of time period for some repairs. And Sneferu is associated with 3 pyramids. He's said to have built the Bent Pyramid, the Vega Pyramid as I call it, the Red Pyramid, or Draco as I call it, and the Medum Step Pyramid. So in classical Egyptology, they say he built 3 pyramids, which is highly unlikely. I mean, why would a pharaoh need 3 pyramids in the first place? And none of these pyramids have any inscriptions, so they're not identified with any pharaoh whatsoever. And could you even build 3 pyramids within the lifetime of one pharaoh? It does sound a little bit unbelievable. However, instead of building 3 pyramids, perhaps Sneferu is associated with these pyramids because he repaired 3 pyramids. Now that would be something quite prestigious, you know, to have repaired the pyramids during your lifetime, which is quite a big task. So perhaps it was Sneferu who repaired the pyramid 4,500 years ago. And if the pyramid had lasted for, 6,000 or 7,000 years before it required repair work, then the Vega Pyramid was built some 11,000 years ago. Interesting, isn't it? Because the erosional evidence is sort of consistent, and it demonstrates that the pyramids are possibly much older than claimed. The precessional era of Leo, 10,500 years ago, the era when the first Masonic guilds were being established. So it would be nice if better dating analysis was actually done. Perhaps if they could do some mortar dating, carbon dating of the mortar in the new technique that they've made. And there is high-class mortar on the casing blocks at Dashur. Actually, it's really, really nice mortar. If you look at it, it is very, very fine pink mortar. And it is so strong in places that as the blocks have moved, it's not the mortar that gave way, it was the block that split. It's really, really fine mortar. And they could do thermoluminescent dating as well. If you removed a block and tested the part of the block that had always been covered, you could do thermoluminescent dating as well. And that's never been done. But one thing we can be sure of is the date for the pyramids has not yet been conclusively established.